There we go. We are live. So today is 4/11/19. So today what we're going to try and find are equations of a perpendicular bisector. Okay. So we're going to find the equation of a perpendicular bisector. So the equation of perpendicular is going to be a straight line. And so we're going to use, make sure we write this down, we're going to use y equals mx plus b, because that's the equation of a line, right? It's the equation of a line. Okay, and we've done that before. We did that on a warm-up. We're pretty familiar with that equation, right? In fact, that's such an important one. Maybe I'll even highlight it. We'll see how this green. Okay. We learned that in algebra. And we did it a bunch in algebra, right? We should have. So let's see how this works. So let's graph the line segment AB. So -2, -3 is A. I am recording in Aiden. Aiden, I'm recording. And 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and there's B. So I'm going to connect the dots between A and B. And I have a line segment. Now, it's really important that we know that AB is a line segment. It's a line segment because you can't find half of a line. You can't find the middle of a line, but you can find the middle of a line segment, right? So if we want to find the perpendicular bisector of this, we're going to have to find the middle. But before we do that, let's just find the equation of AB. AB by itself. So if I look at AB, and I need some y equals mx plus b, right? Yeah, I can scoot it up, okay? Then I need the slope. Well, one way to get the slope is to just walk it up. Now, there's a slope formula, and you don't need to know the slope formula yet. We'll look at it later, but the easiest way is just rise and run. So let's go ahead. Let's take a journey. Everybody watching? Let's take a journey from A to B. So we're going to go up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We went up 12. And over 1, 2, 3, 4, 5, 6. So we went up 12. So my rise over my run was 12/6, okay? But of course, if we reduce that, it's just doing mini steps, okay? So I rose, I went up 12 and over 6, but if I reduce that, that's 2/1. So let's see. Up 2/1, yep. Up 2/1, yep. Up 2/1, up 2/1, up 2/1, yeah. So the slope does seem like it's up 2/1, right? Now, the next thing we need to know is its y-intercept. Well, that's easy. The y-intercept is sitting right there. There's my y-intercept. So the equation is pretty simple. From here, I can say, okay, the equation of this line is y equals a 2/1x plus 1, right? But that's not really the line I want. I really want the perpendicular bisector. So a couple of words. Perpendicular and bisector. Let's talk about the bisector first, because the bisector is the middle, right? We're going to bisect it, cut it in half. So let's find the middle. So the middle from A to B, if we take half the journey. So the journey is all the way up 12, all the way over 6. Let's do half that journey. So instead of up 12, go up 1, 2, 3, 4, 5, 6, and over 1, 2, 3. That is the midpoint, okay? So that's the middle of AB. So if the middle of AB is at the point 1, 3, that's my midpoint. Okay. So I know the line I'm looking for probably looks something like this. See my blue line? It's got to be at 90, it's like 90 degrees. Looks pretty good, right? Right about there. So if I want to get the exact line, then what I'm going to have to do is look at this perpendicular part. So the perpendicular part comes from its opposite slope. Okay, so to get the perpendicular, it's going to have to be the opposite slope. Okay, thank you. So the slope of AB is up 2/1. Okay, That's the slope of AB. We know that because it's right there, right? Slope of AB is 2 over 1. So if we need the opposite slope, it's going to be a negative 1 over 2. Does that make sense? Totally opposite. We're going to flip it upside down, and we're going to make it negative. Or if it's negative, we'd make it positive. Say it again. We're going to flip it upside down and make it negative, and if it's already negative, we'd make it positive. Opposite, right? If it's positive, make it negative. If it's negative, make it positive. So my new slope, and I'm going to use this symbol, M, little symbol there, is equal to negative 1 over 2, okay? See my little symbol? That's slope, that's perpendicular. That's my little perpendicular symbol, okay? So I can go, all right, I know that I'm going to have a y equals, for this one, a negative 1 over 2x. Now, I need the y-intercept. Well, let's take a journey. So if I go and take a journey, down 1, I'm going to take a journey. I'm going to go down 1 over 2, because that's my new slope. Down 1 over 2, right? Down 1 over 2, right? Or up 1, back 2. The line I'm looking for is this green line. Okay? Draw it in. Okay, there's my green line. And it has a y-intercept also, right? It has a y-intercept, and its y-intercept is right there. So its plus b is there, so let's look at 1, 2, 3.5, so plus 3.5. Okay? Okay, there you go. All right? Can you do this on a quiz or a test?
Yes.
Not too bad, is it? It's pretty simple. Okay, now let's go ahead and make sure you guys open your journals, page 194, okay? Page 194. Page 194, and let's keep looking at what we got. Page 194. You guys doing a great job so far. All right, now, we talked about theorems yesterday, okay? Now let's rewrite that again, okay? What is a theorem? So, a theorem is simply a rule, okay? A theorem is a rule. I want you to write this down. A theorem is a rule that can be proved. Don't worry about it, just ignore it. So it's really a rule, or a math rule since it's math class, okay? A theorem's a math rule that can be proved, okay? By whatever methods we're going to prove it, okay? So the very first theorem we got is this thing called the perpendicular bisector theorem. Let's see what it says, okay? In a plane. What? A plane? Like airplane? No, not an airplane. In a plane. What's a plane? A flat
Please
surface.
excuse the interruption. They are testing the system, so please ignore that bell.
Great. I'll just keep recording, huh? So, plane. All plane is a flat surface, okay? Like this piece of paper is a flat surface, okay? Does that make sense? Now, planes go on forever, so it's pretty impossible for me to show you a real plane. Say it again. Planes go on forever. So it's absolutely impossible for me to show you a real plane, but use your imagination. A flat surface, right, is a plane. It goes on forever. A piece of paper is a great example. So, in a plane, if a point lies on a perpendicular bisector, okay? So a point lies on, so like that, that's like point C, okay? Point C. That's my perpendicular bisector. And then it's equidistant from the endpoint. So equidistant. So that means it would have, this would have to be equal to this. Okay? Then it's equidistant from endpoints from the segments. Okay? So what it's saying is this. If this point is on the perpendicular bisector, then this distance AC, so we know that AC is equal to CB. Now here is something we want to talk about. Yesterday we talked about congruent, right? So they saw equal distance. Now they're talking about the length. The lengths can be equal, okay? As an example, okay? Nick can be the same height as Cameron. You guys agree with that? We wouldn't call them equal. We'd say their heights are equal, okay? So this length is equal to that length. If we want to describe the segments, we'd use congruent. Or we could say then that CA is congruent to CB, okay? Congruent means same shape. Equal means same length, okay? How am I doing? Now the converse is just the opposite. So the converse is going to say just the opposite of what I said here. So the converse says the opposite statement. All right? So let me read the original statement first, and then we'll read the converse. Okay, let me read it again. Okay, ready? Just to be redundant. Ready? If in a plane, point a point lines on the perpendicular bisector, then it's equidistant from the endpoints. Okay, that's what it says. Now let's read the opposite. In a plane, if the point is equidistant, oh, it's just the opposite. If it's equidistant from the endpoints of segment, then it lies on the perpendicular bisector. So it's saying this: if these two sides are equal, then let me keep drawing this line. Then D has to be on that line. Say it again. Saying the opposite. If this is equal to this, then this point D must be on this line. That's all it's saying, okay? That's the converse of it, okay? All right, moving over to the next page, okay? Now here's our angle bisector theorem, same thing. Okay, in geometry we'll see a lot of things called theorems. Theorems are our rules in geometry, okay? So let's read it. If a point lies on the bisector of an angle, so okay, let's see, here is point D. That's point D. Point D is on the bisector. I know that it's a bisector because that angle is equal to that angle. They show you with the little dashes, right? Okay, so then if that happens, then it says that it is equidistant from the two sides of the angle. Okay, so that means that this side here has got to be equal to this side here. That's all it's saying. And it's also perpendicular. Okay, so we can say that then BD is congruent to DC. This side is congruent to this side, or this side is equal to this side, okay? Now it just says the opposite. Remember, the converse is just the opposite. So it says if a point is on the interior of an angle, so point D is on the interior. Is it on the is this the bisector? We don't know. Here's what it's saying. See this line right here, CAD? You guys looking? Everybody looking? Do you see AD? Is that in the middle of the angle? We don't know, except if this is equal to this, it has to be. Saying this, is AD in the middle? We don't know, but we do know now if this side is equal to this side, then D must be on the bisector. Saying just the opposite, okay? All right. That's all I have. What do you think? Pretty easy? Okay, now, let's go ahead and flip the page. Okay, flip the page. Okay, flip the page.